Welcome, everyone, and thank you for joining us today for GCSE Maths Revision, how to deliver targeted confidence building sessions. So it is 4 p.m. and we've got quite a lot to fit in, so I think we will go ahead and get started. But before we do, if you have any questions during the session, please pop them in the Q&A box and we'll answer as many as we can at the end if we have time. Everyone here today will receive the webinar recording along with 5 complete GCSE revision lessons that you can use with your students immediately. And these lessons follow the exact structure that we'll be demonstrating today, and we will share the links to these resources at the end. Along the way, we'll also mention some of our free GCSE maths resources that you can download from the Secondary Maths Resource Library. And just a quick introduction. So for those of you who aren't familiar with third space learning, we provide one-to-one AI maths tutoring for schools. The lesson structure that we're sharing today is the same structure that we use with Sky, our AI tutor. And it's been refined across thousands of tutoring sessions with real students preparing for their GCSEs. And today, Paul is going to show you how to apply that structure to a whole class setting. So before we start, let's introduce ourselves. So I'm Charlotte, and before joining Third Space Learning, I was a primary school teacher for 6 years, and I'm now the content editor here, and my main role is to keep our content up to date and aligned with the latest pedagogy. And joining me today is Paul, who's going to walk us through the lesson structure.
Hello everyone, I'm Paul. I'm the secondary curriculum lead at Third Space Learning. I'm a former maths teacher and a GCSE examiner, and I now oversee all of our secondary maths programs, including lesson design for Sky, who is our AI maths tutor. I'm really looking forward to sharing how this structure works and how you can apply it to your own teaching.
Right. So, in the next 30 minutes, we are going to cover why traditional revision lessons often fail to build student confidence, the 4-stage revision lesson structure that adapts to individual student needs, how to use skill check-ins and checkouts to measure genuine progress. We'll go through a complete walkthrough of an algebraic simplification lesson using this structure, and we'll discuss how you can implement this approach in your classrooms, even with large class sizes. So, Paul, let's start with the problem. Most of us have been there. You've taught a lesson or a topic 3 times, and students are still dropping marks on it in the exam. Why is it that revision so often fails to move students forward?
It all comes down to one thing, and that's that we're teaching before we've diagnosed. So in a traditional revision lesson, we might start with a brief recap, work through an example, and then hand out a practice sheet. Some students are going to fly through that. Others are going to get stuck on question one, and then you're left trying to support 30 different needs at once with no clear picture of who needs what. The deeper problem is that students who already understand the topic are going to sit through explanations they don't need, while students who have a specific gap, like a sign error or a misconception about like terms, well, they're going to get a general explanation that doesn't really address that actual problem. So neither group is going to make the progress they should. And in GCSE revision, we know that every lesson is going to count. So we can't afford to spend 50 minutes explaining something half the room already knows. And we can't afford to let students practice a method that they've half understood, because that's just going to reinforce that error.
So, am I right in thinking then that the structure we are about to look at essentially inverts that? It diagnoses first and then teaches to what students actually need.
Yeah, exactly. And crucially, it gives you data that you can use beyond a single lesson. So by the end of today, we're going to have a clear framework for knowing at a glance which students are securing topics, which need a bit more time across your entire revision program, not just one lesson. So this framework is going to diagnose what students know at the start and then adapt that support based on that diagnosis and measure the progress by the end. Every student gets the right level of challenge, and you get a clear set of data on who's made progress and who needs a little more support. When students receive targeted help and then demonstrate they can do it independently, that's where they see visible progress. And it's a really powerful motivator, especially for students who've convinced themselves they just can't do maths.
Yeah, absolutely. I think we all know the power of a growth mindset, particularly in maths. Okay, let's break this structure down so that teachers and whole maths departments can use it consistently. So, Paul, can you walk us through the 4 stages of a maths GCSE revision lesson?
Absolutely. So, 4 stages. We've got you try, which is the skill check-in. We've got targeted support. We then got a your turn, which is the guided practice. And then we've got a check for understanding, which is the skill checkout. So let's look at each one. Stage one is the skill check-in. So students answer one question independently, no hints, no scaffolding. You just observe. So this is your diagnostic. You're not looking for right or wrong answers at this stage. You're looking at what each student does and and where they go wrong. So that's going to tell you everything you need to know about what to teach next. So a good checking question needs to be very carefully chosen. It should be pitched at the level you're revising. So for a targeting grade 4 class, something like expanding and simplifying 3 bracket 2x plus 1 subtract 2 bracket x minus 4. It needs to be complex enough to surface common errors, but not so multi-step that you can't pinpoint where that breakdown is. And we'll come back to that in the walkthrough.
Okay, so the diagnostic power then, it comes from choosing the right question, not just observing whether or right the students are getting it right or wrong.
Yeah, precisely. Okay, so then stage two. Stage two is targeted support. This is where you're going to respond to what the check-in revealed. And I want to be really clear here about what targeted means. We're not reteaching the whole topic. We're addressing the specific gap. So in the walkthrough, we'll go through a range of different errors that you're likely to see. But to give you a sense of what I mean, a student who drops a sign when expanding the second bracket just needs 2 minutes on negative numbers. They don't necessarily need a full explanation on how expanding works. Whereas a student who only multiplies the first term inside the bracket, well, they've got a more fundamental gap and they're going to need a different response entirely. So we've got the same topic, same question, but completely different support. Right, let's look at stage three. So this is the guided practice. This is the your turn. Students are going to work on similar questions, but with some limited support here. The key word here is sequenced. We're going to start simple and then increase complexity gradually. We want students to build fluency step by step, not leap to the hardest version immediately. And this is also where misconceptions that didn't necessarily show up in the check-in are going to surface. So a student might handle one bracket confidently and then show a gap when you introduce a coefficient outside that bracket. And then finally, stage four. So stage four is the skill check out. Here, students answer a question independently at the same level as the check-in. And this is going to give you a direct comparison. And alongside the answer, you're going to ask students to give you a thumbs up or a thumbs down on their confidence. And that confidence signal is almost as important as the answer itself. A student who gets the checkout right but gives a thumbs down, well, they're telling you something really quite important. They followed the steps for that specific question, but they don't yet feel secure applying the method more broadly. And that's a student who needs more varied practice before they sit their exam.
Yeah, definitely. And in an exam, I think that's exactly where the pressure hits, isn't it? So, especially if you've got a question that looks slightly different from something they've seen before, or you've got a student who gets a question right but says, I'm not confident, they're probably going to need a bit of extra help so they don't struggle under the exam conditions with the added pressure of timing and everything.
Yeah, exactly. And that thumbs down, well, that means don't move on just yet. They're going to need a bit more practice, more varied examples, or just a bit more reassurance that they understand the underlying principle, not just the procedure. So more on what to do with that data when we talk about tracking in a little bit.
And just before we look through a full lesson example, can you explain just quickly why this structure is particularly suited to GCSE revision?
Yeah, absolutely. There's four reasons. So this works really well where traditional revision doesn't. So reason one is that it's really adaptive. We're not assuming all students are starting at the same point. So that check-in tells you exactly what each student needs. So you're not wasting time reteaching students who already understand or pitching content above students who aren't quite ready for it. And number two, it's really, really efficient. In a traditional lesson, we might spend 15 minutes explaining a concept that maybe half the room already understands. But with this structure, we're going to diagnose first. Students who get the check-in right, they're going to move straight to consolidation practice, while you focus your time on the students who really need that extra support. Number three, it's going to build confidence. So students answer a question independently at the start, they get some help, and then they can prove to themselves and to you that they can do it at the end. That's a complete learning cycle in a single lesson. And it's a particularly powerful experience for students who've convinced themselves that they're just not good enough at maths. They absolutely are. And now we've got some evidence that you can point to show that they can do it. And number four, it's going to give you some really usable, clear data. So not just a sense of how the lesson went, but a specific record of which students closed the gap and which still need a bit more time. So that's what makes it really useful beyond a single class. More on that when we talk about tracking in a few slides' time.
I think that last point is worth highlighting for anyone who leads a maths department as well as teachers. Like running this structure consistently across year 11 or even year 10, it gives you something that you can actually act on. So it's not just mock scores, but it's a topic by topic gap data across your whole cohort. Okay, so just before we go through that lesson, I know some of you are probably thinking this sounds great in a one-to-one tutoring context, but how does it translate into a class of 30 with no TA? Um, that's what we're going to show you in this walkthrough, is how to do that with a whole class, not just in like a one-to-one or a small group situation. So we'll be quite specific about the strategies to make that manageable for you. So without further ado, Paul, could you walk us through a full GCSE lesson on algebraic simplification?
Absolutely. So we're going to use expanding and simplifying expressions with brackets. And we're going to do this because it's a topic that appears consistently across papers and it generates a wide range of misconceptions. And students can often make consistent errors here, and that's going to cost them marks. So in one of these revision lessons, we might see 5 or 6 different errors. Understanding what those errors look like and how to respond to each of them is the real skill here.
So how would we start this session?
So we kick things off with our all-important skill checking question. Remember, there's no hints here, there's no scaffolding. You're simply observing who can do it, who's attempting a method, and who doesn't know where to start. So the example might be expand and simplify 3 bracket 2x plus 1 subtract 2 bracket x subtract 4. We're looking at their working out here, not just the final answer. So let's give some examples of what you might actually see in the room. I'll go through each response one by one because each one's going to tell you something different. So, response A, correct answer. Lovely. So this student apparently understands the method fully. So they've handled the negative multiplier correctly, collected the like terms, very nice. They're not going to need your time on stage 2. Response B. Here we've got a correct expansion, but we'll see there's a sign error in that second bracket. This is probably the most common error we'll see. The students multiplied -2 by x correctly, but they've treated -2 multiplied by -4 as -8 instead of +8. They've forgotten about the negative times negative giving a positive. So that's really specific and a fixable gap. It's not a fundamental misunderstanding of expanding brackets. All right, student C. Here we've got a partial expansion, so only expanding the first bracket, but we've not expanded the second one. They've just rewritten it. So they might not have read the instructions fully, or they may not have understood that the minus sign applies to the entire second bracket. A bit more to delve into there. Student D. Here we've got an incorrect distribution, so multiplying only the first term inside each bracket. This student seems to understand the need to multiply the term outside the bracket by something inside, but they're only applying it to the first term. The +1 and -4 have been left unchanged. So this is a more foundational gap in the understanding about what expanding brackets really means. Okay, student E, well, here we've got a correct expansion, but collecting unlike terms. So the student has managed to merge their x terms and their constant terms, or they've written 11x instead of 11. So this is a like terms error, which is separate from the expansion. And finally, response F. Here, no working shown. Blank, or maybe there's a question mark. This student seems to not know where to start, so we might need to go back to basics on expanding single brackets before they can even attempt this one.
This is great. So kind of just within a few minutes of students answering that question and checking their answers, you kind of have a good picture of where everyone is in the room. And at the minute, you haven't even taught anything yet.
Yeah, exactly. And this is why the checking question design really matters. So A simpler question, let's say just expand 2 bracket x plus 3, that isn't going to surface errors B, C, and D. But choosing that 2 bracket structure with a negative multiplier, we've chosen that specifically to expose those misconceptions that are most likely to cost students marks.
Okay. So now you've identified the different levels of understanding. What do you do next?
What do we do next? So we now need to respond to what we've seen. And here's the practical reality. You're not going to deliver 6 different explanations to 6 different students simultaneously. It's not possible. You're one person. What we're going to do is try and group students together by error type and then address each group efficiently. So let's look at each one. So group A, these are the students that got it right. So they can now move immediately on to independent practice with a few more complex questions. We're not going to spend time with this group straight away. Group B, though, well, this is the group with the sign error, and this is probably the largest group. So we're going to bring them together. Here, the correction is very specific. So when you expand negative 2 bracket x minus 4, you multiply the negative 2 by every term inside. So we can write it out explicitly. We can ask students questions around what is negative 2 times negative 4? Ask them why. That's where that misconception lives. So many students here have learned a rule without really understanding it. And if we have a visualizer, love a visualizer, show one of the students working and maybe correct it together. It's going to take 3 minutes for the whole group to go through this specific problem. Group C. Well, here they didn't expand the second bracket. So maybe this group, we're going to ask them to read the question again. Maybe get them to explain what expand and simplify means. Usually they probably know they've just applied it inconsistently. So model what it means. Treat the minus sign as belonging to the multiplier. Negative 2 bracket x minus 4 is the same as multiplying negative 2 by every term. Once they see that, they might be able to correct it for themselves. Group D. Okay, now these are the students that only multiplied that first term. So this is a more fundamental gap. Use a visual if you can, maybe an area model, maybe a grid showing what it means to multiply a term by everything inside the bracket. You want them to see that 3 bracket 2x plus 1 means 3 lots of 2x plus 3 lots of 1. This group might need a bit more time, so flag them for some follow-up. E. So this was the like terms error. So quick correction. Ask them to circle all the x terms and all the constant terms separately before they start collecting. Here, the expansion was absolutely fine. So this is a procedural slip, not a conceptual gap. And finally, group F, well, these people couldn't start at all. So these students are going to need that one-to-one support. Work with them directly, maybe start with a single bracket, 3 bracket 2x plus 1. Can they do that? If yes, let's move on to single brackets with a negative, get them secure on each step before combining with the 2 brackets.
Okay, and I know that this is where having a TA is obviously incredibly valuable, but most teachers won't. So what's the realistic version here for someone who's got a class of 30 plus students on their own? How can they make this feasible?
Yeah, it's really, really tough. I mean, honestly, you're not going to reach every group in a single pass. The practical strategy is get the group A students working independently, address group B as a group using a visualizer, because maybe that's your biggest group, and then do a round of the room for group C, D, and E. For response F students, maybe flag these for one-to-one support during the guided practice phase. You can't do everything at once, but what you can do is make sure every student knows what their specific next step is. So this is where preparing resources really, really helps. So if you've got a targeted practice sheet ready for your Group B students, maybe 5 questions specifically for practicing negative multipliers, and they can work on that while you work with another group. You're not creating these from scratch every lesson. Make them once, and then you can reuse them every time you teach the topic. Now, let's look at what happens next. So we're going to move on now to the your turn guided practice phase. Here is where students practice. These questions need to be very carefully sequenced. So here's what this could look like. So question 1, expand and simplify 4 bracket 4 bracket 2 minus x plus 5 bracket x minus 1. This mirrors that check-in structure. It's at the same level, 2 brackets, 1 negative multiplier. Second question, well, this time we're going to expand and simplify 5 bracket a plus 2, subtract 3 bracket a minus 4. Here, both brackets have a subtraction inside. Now, this is going to increase the chance of sign errors. Students who are still uncertain about the negative multipliers, they're going to show up here. And the third question, well, let's make things a bit more interesting. Here we've got variables outside the brackets. Students who secure the two bracket version now get an opportunity to apply it to a question with a little bit more complexity. The sequencing matters here. If students jump to question 3, the students who made the errors in the check-in might be overwhelmed, probably will be overwhelmed, before they consolidated that correction. Starting super simple lets them experience success, and then we're going to increase the difficulty. And that's what builds the confidence, and that is going to show up, hopefully, in this checkout question. So students who got the check-in question correct, they can start on maybe question 2 or 3. Students who didn't, maybe they need to go to question 1 first.
Oh, this is really helpful. So we've had the skill check-in, the targeted practice, the independent practice. How then would you round off the lesson?
So now we're going to do the checkout question. So this is the same structure as the check-in, two brackets, negative multiplier, but different numbers. Students are going to answer this independently.
And then the confidence check that we mentioned as well, does that happen here too?
Yes, absolutely. So we ask students then to rate how they're feeling now compared to the start of the lesson. So some really interesting ways to read these results. So if a student went from wrong to right, potentially a closed gap, good progress. A student who's gone from wrong to wrong, well, this is a priority. We're not going to move on just yet. They need more time. A student who got both right, potentially secure. Maybe they're ready to move on. A student who got the checkout right, but then gave a thumbs down in the confidence, they're going to need a bit more confidence building. So give them more varied practice. They've understood the specific question type, but they don't feel confident applying the underlying method. That's the student who's going to struggle in the exam if the question looks slightly different to what they practiced.
That's great. Okay, so we've now gone through the lesson and we've spoken a bit about like adapting it for a whole class, but could you tell us some things that can make that really manageable, really practical for a teacher?
Absolutely. So, three things that are going to make this manageable for an entire class. So, number one, have your resources prepared in advance. Any topic you're revising, maybe prepare 4 things before the lesson. Check-in question, targeted practice sheet, one for each of the 2 or 3 most common errors, a sequence set of guided practice questions, and then that checkout question. So for algebraic simplification, the one we've just been through, maybe that means a sheet on negative multipliers, something on a like terms error, something for students who need to take a step back and go to single brackets. Once these have been made, you can use them every single time we revise this topic. The prep time is front-loaded, not repeated.
And I think we know how time intensive sometimes creating these resources can be. So we do also have topic specific GCSE worksheets in our secondary resource library that you can use. Actually, we have hundreds of ready-made GCSE revision resources that you can use to support these lessons. You can just follow the QR code on the screen here. And then we also have guidance in a blog on using AI tools to support resource creation. So we actually have a blog on using ChatGPT for maths. So again, there's a QR code on the screen. If anyone is using AI tools for resource creation, anything like that, we do always recommend checking anything AI generated carefully before using it with students, of course.
Yeah, absolutely. Okay, number 2. If you're lucky enough, use a visualizer or maybe a mini whiteboard. Love a visualizer. This is great for that targeted support phase. If 5 students have made the same sign error, bring them together. Work through the correction once with one student working on the visualizer. I mean, that's going to be way more efficient than explaining the same thing 5 times individually. Meanwhile, the rest of the class are working independently on either consolidation or targeted practice. And tip number 3, the tracking sheet. So at the end of the lesson, we're going to have 3 data points for every student, a check-in result, a check-out result, and a confidence check. And that tracking sheet, we're going to send you one today at the end of this webinar, is that's got space for all 3 of these data points. It's going to take 30 seconds to fill in after the lesson, and that's going to give you a really clear record that you can use across your whole revision program.
Okay, so just to check, you're not recording anything complicated. It's essentially whether the student got the skill check-in right or wrong, whether they got the skill checkout right or wrong, and then also kind of just tracking their confidence as well, whether they're giving you that thumbs up or thumbs down.
Yeah, exactly. That's enough. Over 5 or 6 topics, patterns are going to emerge very, very quickly. You'll see students who are consistently giving them down even when they're getting the right answer, and they're going to need a bit more reassurance, a bit more varied practice. And you'll see students who got it wrong on the check-in for multiple topics, so they might need more intensive support or maybe a different approach to revision altogether. The data isn't complicated, but it is specific, and it's much more useful than just using mock exam data on its own. So this is exactly where Sky, our AI maths tutor, is so effective for GCSE revision. Every Sky session follows the exact structure that we've gone through today and collects this data for you. But it's delivered one-to-one, which means that every student is going to get personalized support without adding to your workload. The lessons you're receiving today are the same lessons that Sky delivers, so you can see exactly how this structure works or edit it, feel free to change it for your own classroom.
And just thinking about the data for using it in class, could you also use this at a department level as well?
Oh, absolutely. And this is where it becomes a genuinely powerful tool for heads of maths and revision leads. If every teacher in your department is running a structure like this, then you can aggregate the check-in and check-out data across multiple classes and identify topics where students across year 11 need more support. So maybe it's algebraic simplification, maybe it's calculating fractions, maybe it's a specific question type in the higher paper. It's going to tell you two main things: which topics need more time in your revision schedule, and which topics might need a different teaching approach altogether. It also gives you a basis for peer-to-peer observation. It's unbelievably powerful to do that. A teacher whose students are closing the gap on a particular topic might be doing something really special, and that's worth sharing with the whole department. So when you pair this with your mock exam data, it's going to give you a really clear, full picture. Not just the overall score, but which skills have been secured and which are still open gaps going into those exams. And we have a host of GCSE maths practice papers for both higher and foundation tiers across Edexcel, AQA, and OCR that you can use as mock papers. And the best news is, Charlotte, there's brand new ones coming out imminently for 2026.
Well, I think I actually have even more exciting news. I think that they actually landed today.
That is very exciting.
So if you want to scan the QR code on the screen, they will take you to our brand new sets of papers for 2026, which is very exciting. And also, if you want to implement this across your department, the 5 lessons that we're sending to you today, they're a great ready-made starting point for departmental CPD sessions. You can run through the structure together and assign topics, agree on shared check-in and check-out questions across classes, and then that way your data is comparable across your whole cohort as well. So, Paul, someone wanting to try this out later this week or next week, what is the fastest way that they can get started?
Don't try to overhaul your entire revision program overnight. Start by using one of the 5 lessons we're sending you. Pick a topic your class has struggled with, run the lesson as written, and then fill in the tracking sheet at the end. That's it. You don't need to run, sorry, you just need to run one lesson and then see what the data tells you. You don't need to complicate it to begin with. If you want to build your own check-in questions out of that, the key design rule is choose a question complex enough to surface the most common errors for that topic, but not so multi-step that you can't identify where the breakdown happened. So for algebraic simplification, that's a two-bracket expression, maybe with a negative multiplier. For solving equations, that might be a two-step equation. Maybe it's got unknowns on both sides. Think about what the most expensive errors are, the ones that cost students the most marks in the exam, and then design your check-in to expose them.
Amazing. And just as a reminder as well, all those free resources are there in the secondary maths resource library if you don't want to start from scratch. The topic-specific practice questions, revision maths, past papers, and including those brand new ones for 2026. Okay, so I think we are about to wrap up, but Before we do, just a quick reminder of what you're receiving today. We've had a few questions come in about the webinar recording. Everyone will receive the webinar recording along with the 5 complete GCSE revision lessons that follow the exact structure that Paul has walked through today. And you can adapt these as well for different GCSE grades. Everyone will also receive a tracking sheet as well to track the skill check-ins, skill check-outs that we mentioned. And also there are the links to the secondary maths resource library as well.
And if you'd like to see how this structure scales using AI tutoring, every Sky session follows the same four-stage approach, so it's personalized for each student without adding to your workload. So if you want to find out more, please do get in touch. We'd love to hear from you at hello@thirdspace.learning.com, or if you visit thirdspace.learning.com, you can register your interest on there.
Amazing. Paul, thank you so much for walking us through this today. And thank you to everyone who's joined us. We know that GCSE revision season can be quite pressured, but we hope that this gives you something really concrete to take back to your classrooms that you can work with.
Best of luck, everybody, with your revision planning, and thank you so much for joining us this afternoon.
Thank you.